Allow me to elucidate Archimedes' method, a geometric technique employed to approximate pi by delineating a circle with rectilinear figures. By inscribing a polygon within the circle and circumscribing another polygon about the circle, Archimedes astutely deduced that the true circumference must necessarily reside between their respective perimeters.
Consider, if you will, a detailed examination of the mathematics involved. First, the side length. Should one divide a regular n-gon into n triangles, emanating from the center, the angle subtended by each slice becomes 2 pi over n. Employing trigonometry on a triangle possessing a radius of unity, the length of one side of the inscribed polygon is precisely 2 sine of pi over n.
The value presented is the partial sum of the Leibniz series, utilizing precisely 300 terms, where n equals 300. Because the formula stipulates that the complete infinite sum equals pi over 4, this result constitutes an approximation. Your sum is 0.784565. Step elucidates Euler's formula, that remarkable connection between exponential progression and circular geometry. Firstly, observe rotation, not growth. Ordinarily, e to the x indicates a process of enlargement. However, when the exponent is multiplied by the imaginary unit I, the apparent growth is translated into a novel dimension, thereby becoming a rotation. Secondly, the coordinates. The formula e to the I theta equals theta plus I theta specifies precisely the terminal point of the rotation. The real component, theta, represents the horizontal axis, while the imaginary component, theta, constitutes the vertical axis. Thirdly, we have the unit circle. Given that squared theta plus squared theta equals 1, the length of the vector is invariably equal to 1. As theta increases, the terminus of the vector delineates the unit circle perfectly. Would you care? One might describe Euler's identity as the, shall we say, apogee of mathematical elegance. It presents a profound unification, linking 5 seemingly disparate constants into a single, harmonious statement. First, e, the base of natural logarithms, the foundation of exponential growth. Second, I, the imaginary unit, the square root of -1, which furnishes the dimension requisite for rotation. Third, the ratio of a circle's circumference to its diameter, a most familiar transcendental number. Fourth, 1, the multiplicative identity, the point of commencement, if you will. And fifth, 0. The additive identity. The azure surface is defined by z equals e to the power of minus, open parenthesis, x squared plus y squared, close parenthesis. Because the exponent depends solely on the distance from the origin, where r squared equals x squared plus y squared, the shape assumes perfect circularity. The golden line represents the cross-section, e to the power of minus x squared, along the x-axis. When we calculate the area under that golden curve, we find it equals the square root of pi.